Alright, in this video I'll be going over the first part of Test 5 review, the Test 5 review. So let's go ahead and get started. It says determine whether each relation has symmetry, and what I mean by that is either x-axis symmetry, y-axis symmetry, origin symmetry, or none of these three. So if you look at the first graph here, it looks like you might have origin symmetry if you had a point like right here. The only problem is it doesn't go through 0, 0. So it's not going to have origin symmetry. In fact, this one has no symmetry, or we'll just say none. Now when you look at B, this one does. Notice it does go through 0, 0. And if you pick any point on this side, we'll just choose that one there, and you draw a line, you draw a line from there through the origin, straight line to the opposite side, you'll find a point on the opposite side. So for every point over here, you can reflect that point through here and you'll find a point on the opposite side. So that's what it means to have origin symmetry. It's really symmetry through just a point, the point 0, 0. Notice this one does not have that. And so this is origin symmetry. And then this last one, if you actually drew a line right down the y-axis, this side is a mirror image of this side. So if you pick any point over here, like 3, or what is that, 5, 1? 4, 1. You'll find a point on the opposite side 4 away as well. So we're 4 to the right at this point, will be 4 to the left at that point. And so this y-axis is a line of symmetry. So here we have y-axis symmetry. All right, let's move on to number 2. Now it says use the algebra test to determine whether each function's even, odd, or neither. So there's a test we have. What we do is we replace x with minus x. And when we do that, if we get f of x, the original function, then we say the function is an even function and it has y-axis symmetry. If we do plug in minus x and we end up with minus, or the opposite of the original function, then we have what's called an odd function. Odd functions have origin symmetry. So here we'll replace x with minus x. We're just replacing each x with minus x. Now notice if you multiply minus x times minus x times minus x, multiplying an odd number of negatives, you're going to get a negative x cubed. We'll put the negative out front in front of the 2. And so this term becomes negative 2x cubed. And then minus a negative here, this will be plus x. Now notice the terms are the opposite signs of what they were originally. Right? Minus 2x cubed plus x, opposite of what we started with. So I could say this is the opposite of the original function x, f of x. And so this is a case where this is an odd function. And again, you should know that odd functions have origin symmetry. So this function has origin symmetry. If we do the same thing on b, we'll get 3 times minus x minus 7, which is a negative 3x minus 7. Now notice that does not equal the original function, and it doesn't equal the opposite of the original function, because even though the 3x changed signs, the minus 7 did not. It's not like here where both terms change signs. And so this is a case where we would say neither. We don't have any of these symmetries, or I should say we're not even or odd. Okay, and then we do the same thing here on letter C. It'll be minus x to the 4th power plus 6. And we know if we multiply 4 negative numbers, minus x times itself 4 times, we're going to get a positive answer. It'll be x to the 4th. and then we bring down the 6. And so notice we're back to the original function. And so replacing x with minus x doesn't change the original function. That's the case where you have an even function. And again, if I asked you about the symmetry, we would have y-axis symmetry. It's like this function here. All right, let's go on to number 3. So on number 3, this deals with a transformation. It says write an equation for the function that has the same shape as f of x equals the absolute value of x, but is reflected through the x-axis, shifted right 3 and down 1. Well, first of all, we know that f of x equals absolute value of x looks like this. So if I want it to be reflected through the x-axis, we'll have f of x equals minus, and we'll put x in here. Now, we know that if we put a number inside the absolute value, that causes a horizontal shift this way. And since we're going right 3, remember horizontal shifts are the opposite of what you expect. I would think you'd put a plus 3, but it's a minus 3. And then finally, shifted down 1, that would mean we have a minus 1 here. So remember, a number separate from the absolute value causes a vertical shift, and if it's minus 1, that means it's down 1. And a number inside the absolute value with x here is going to cause a horizontal shift. Those are the ones that work the opposite of what we would expect. And so minus 3 causes us to go right 3, which is what we have here. And again, the negative out front is for the reflection. So this is correct. So it's always a good idea to, because most students are able to go from this and tell me about the shifts. We're just going in the opposite direction. So it makes sense to just check it by going in the reverse direction. All right, let's move on to number 4. All right, so we have two complex numbers here, which are of the form a plus bi. And what we learned is these act just like algebraic expressions. In this case, we would drop the parentheses or ignore the parentheses. Actually, I'm sorry, we do have to distribute the negative 1 here, since there's a minus in front of parentheses. This is a negative 1, and when we multiply each of those terms by negative 1, the signs change. So now we can add our like terms. We have 12 and minus 7 is 5. 4i and 9i make 13i. Notice when we subtract two complex numbers, we get a complex number. 5 is the real part, 13i is the imaginary part. All right, on number 5, now we've got a FOIL, just like we would if these were x's. We get 18 minus 6i plus 30i minus 10i squared. Now, you can see that we have two like terms here. 30 minus 6, that's 24, so 24i. Now remember, I squared is negative 1. So this is 18 plus 10. We're going to get 28 plus 24i. All right. On number 6, you've got to be careful. You can't just square the 4 and square the 8i and then put a minus in between. There's no shortcut for doing what we have here. This is 4 minus 8i quantity squared, which indicates that we need to multiply two of these. So 4 minus 8i times 4 minus 8i. And now it's just like number 5. We're just going to FOIL. So the first product is 16. The outer product is a minus 32i. The inner product is minus 32i. And the last product is plus 64i squared. And I'm going to go ahead and shut my air conditioner off real quick. All right, let's get back to work here. It'll take a minute to shut off. So we have 16 minus, let's see, 32, and 32, that'll be a minus 64i. And this is plus 64 times negative 1, since I squared is negative 1. So this will be negative 64 plus 16, which is negative 48, minus 64i. All right, let's move on to number 7. So we're going to need the conjugate to get, see, this is not in the form a plus bi. We've got a denominator that's a complex number, or imaginary number in this case. More specifically, we want to use the conjugate, which would be 5 plus 2i. It's always the conjugate of the denominator. We're trying to get the I out of the denominator. So we could write this as 5 minus 2i times 5 plus 2i, and we'll put the same thing in the numerator, so we're multiplying by something that's equal to 1, which makes it legal. So we have 8 times 5 plus 2i over 5 minus 2i times 5 plus 2i. So when we distribute in the numerator, we'll get 40 plus 16i. In the denominator, now remember, we can FOIL this out, but our inner product and our outer product, one's going to be 10i and one will be negative 10i. Those are going to add up to 0. Anytime we do multiplication with conjugates, this happens. So we really just need to multiply the first terms and the last terms. So we get 25 minus 4i squared. Now remember, I squared is negative 1. So we're going to get 40 plus 16i over 29, 25 plus 4. Now we want to write this in the form a plus bi. So our a will be 40 over 29, that's the real part of our answer, plus 16 over 29 times I. So this will be the imaginary part of our answer. All right, let's move on to the next page. Oh, let's see what happened here. There we go. I covered up my paper. All right, so number 8, we're just practicing completing the square. So basically we have a binomial in the form x squared plus some number times x, and because we have a 1x squared and an even number here, it's easy to create a perfect square trinomial out of this. What we do is we take half of 8, so 8 over 2, and we square it. Well, that's 4 squared, which is 16, and so that's why we're going to add 16 here. And so now we want to write it in its perfect squared form. Well, we know x times itself, or x squared, gives us that. And over here, it's really whatever we get when we took half here, which was 4. And so that's what's going to go here. Notice 4 squared does give us 16. And we learned to get the middle term, you multiply these two, x times 4, that's 4x, and double it. And so that is correct. All of this is based on patterns that we saw. So hopefully you can do this one if you didn't get A the first time. All right, let's see how you did. So we'll take half of our b term, which is negative 20. We'll divide that by 2 and square it. And that's what's going to go here. So negative 10 squared is 100. And notice I do have a minus here because when I take half of 20, that's negative 10. The negative 10 is what goes here. And you can always double check it. X times itself is x squared. Negative 10 times itself is 100. If you multiply these, you get negative 10x. Double that, that's your middle term. So that's the pattern that we've picked up on. All right, let's look at how to simplify each radical here. Well, square root of 9 is 3. The minus is going to stay out front. It's really like negative 1 times square root of 9. And we always do a square root, just like we do exponents, before we do any kind of multiplication. So take the square root of 9, multiply by negative 1. So here we're looking for a number that in the past we used to say there's not a real number answer here because there's no number that you square and it gives you negative 9. So what we learned is we can write this as the square root of 9 times the square root of negative 1. And so this would be 3, and the square root of negative 1 we said is I. So the answer here is 3i. This is the exact same problem, except first we have to find the square root of negative 9, which is 3i, and then we apply the negative, or multiply by negative 1, however you want to think of that. Here the only thing I can do is pull out an I. It would be square root of 11 times I. In fact, after a while you may be going directly from there to there. Anytime you have a negative under the radical, you can just pull out an I. It's equivalent to what we just did here. On this last one here, we could write this as the square root of 20 times the square root of negative 1, or the square root of 20 times I. Now remember, the square root of 20, because it has a perfect square factor of 4, we could write this as the square root of 4 times square root of 5. In fact, it's not square root of 20 is not simplified because it has a perfect square factor of 4. So this reduces or simplifies to 2 square roots of 5. So the answer we get here is 2 square roots of 5 times I. Now on number 10, when you're doing the quadratic formula, when you get towards the end, you'll end up with an expression like these. And these can be a challenge to simplify. You certainly need to know how to simplify radicals. But anyway, that's what we're doing here, is just practicing. Now keep in mind there's two answers represented by what we see here. Negative 8 plus the square root of 10 over 6, and negative 8 minus the 10 over 6. No square root. So negative 8 plus 10 over 6, that's one of my answers. Well, that's 2. Negative 8 plus 10 is 2. 2 6, or 1/3. The other answer, I'll just put it right here. Negative 8 minus 10 over 6. That's negative 18 over 6, which is negative 3. So the two answers in simplified form are 1/3 and negative 3. You would not want to leave an answer like that. Now, if you look at this one here, we have to find the square root of 40. That one, notice, has a factor of 4. That's a perfect square. So we could write this as square root of 4 times square root of 10, or 2 square roots of 10. So I'm just going to replace the square root of 40 with 2 square roots of 10. So we'll have 6 over 4, 6 over the 4, plus or minus 2 square roots of 10 over 4. So that'll be 3 halves, plus or minus, it's really 1/2 here, but you don't really need to write the 10 or the 1 in the numerator. So this is a 1, right? So 2/4 reduces to 1/2, but you can write the 1 there or not. Normally we just leave it like that. Let's go on to letter C. Now for this radical, there are no perfect square factors of 10, but we do have a negative under the radical, so we can pull out an I. Remember, this is the square root of 10 times square root of negative 1, or the square root of 10i. So we have 4 over 2, plus or minus square root of 10 times I over 2. And of course, 4 over 2 is 2, so we have 2 plus or minus the square root of 10 over 2 times I. Now on number 11, I tell you to use the square root method, but that's the obvious choice, mainly because there is no x term. That's what we learned. there's no x term, the square root method is going to be the method to go with. In this case, we want to get x squared by itself, so let's get rid of the 3. We get x squared is equal to 16. We'll take the square root of both sides. Whoops, let me get a pen so I can make it stand out a little bit better. So notice I rewrite it because I'd like you to see each of the steps. Sometimes we'll do all our work in one little place, and by the time we're done, you can't tell what you did. So this helps you to see step by step what we did. So of course the square root of x squared is x, and the square root of 16 is 4, so this is plus or minus 4. Now on a test, I would be okay with you giving that answer, but just understand that means there's 2 answers, -4 and 4. All right, let's move on to number 12. So just again, talking about quadratic equations, we have 4 ways that we solve them. Factoring, the square root method, completing the square, and the quadratic formula. For the factoring method and using the quadratic formula, you want to have equations in this form. It's called standard form. But for completing the square, and also notice square root method, we try to get the squared part by itself, so that's a little bit different. But for factoring and quadratic formula, we need it in this standard form. But for completing the square, we want to isolate these 2 terms here. We want to get rid of that 22. So we'll add 22 on both sides. So we get x squared plus 10x is equal to 22. So that's, oops, I forgot my x. That's our first step. So now we want to complete the square on the, and create a perfect square trinomial here. And so we'll take the x squared plus 10x. Now I like to make a little square here, but you just need to add a number there. For me, it's a visual, putting a little square in there. So I'll take half of 10, which is 5, and I'll square that, and I get 25. So we'll add 25 to both sides. Remember, whatever you do to one side, you do to the other. Now, it looks like we might have made things look more complicated. It kind of does look a little more complicated. But the whole point of this is now we can write this perfect square trinomial as a perfect square. I'm going to go ahead and do that here. And remember, half of the 10x, that's what goes here, or half of the 10, that 5 goes here, and that's squared. And on the other side, we have 22 plus 25, which is 47. Notice, if you multiplied 2x plus 5's out, you'd have x times x, you'd get x squared. 5 times 5 would be the 25. Remember, if we multiply the 5 and the x here, we get 5x. Double that, that's your middle term. This does equal this trinomial if you multiply it out. So all we're doing is changing it to its squared form, so now we can take the square root of both sides. So let's go ahead and do that. Remember, squaring and taking a square root, those are opposites, so we end up with just x plus 5 here. On the other side, the square root of 47. Let's go ahead and subtract 5 on each side. We get -5 plus or minus the square root of 47. Now 47 doesn't have any perfect square factors, and so we're done there. Notice also we can't combine a radical with just a plain term. You can only add a square root of 47 term with another square root of 47 term. So we're all done there. And again, keep in mind there's 2 answers, -5 plus square root of 47 and -5 minus square root of 47. All right, last one here. Number 13, you got to know the quadratic formula. It's x equals minus b plus or minus square root b squared minus 4ac all over 2a. We even did the quadratic formula song in class to the song Pop Goes the Weasel. So x equals minus b plus or minus square root b squared minus 4ac all over 2a. That's how you memorize this thing. At least it worked for some. So let's go ahead and plug in the numbers. Notice here A is 2. Be careful here, B is -2, and C is 5. So if you have a subtraction, you have to use that sign, that negative sign. All right, so let's plug in our numbers. We have negative B, or -2. I'm sorry, B is -2. Plus or minus square root. Again, B is -2 squared. Notice I'm squaring -2. That's B squared minus 4 times AC. So A is 2 and C is 5. And then over 2 times A, or 2. So we're going to get 2 plus or minus. Now notice here, this is -2 squared, and -2 times -2 gives you a +4, minus, we have 4 times 2 times 5, that's 8 times 5, which is 40. 4 minus 40, we end up with the square root of -36. Now remember, the square root of -36 is the square root of 36 times the square root of -1, or 6i. So we're going to end up with 2 over 4 plus or minus 6i over 4, which is 1/2 plus or minus 3/2 times the square root of I. So that's our x. Oops, sorry, I went off the grid there. All right, so that's it for the first part here. We're going to stop right there, and then we'll move on with a separate video, the next video.